In the last unit, we learned about different kinds of lines, perpendicular lines, parallel lines, and skewed lines. In this unit, we specifically focus on perpendicular lines and theorems about perpendicular lines. The first two theorems, 3.1 and 3.2, are listed here. 3.1 says all right angles, meaning all angles that measure 90 degrees, are congruent. And we can just use this symbol. So if we use mathematics, we say if the first angle is 90 degrees and the second angle is 90 degrees, therefore the first angle A is congruent to the second angle B. That's theorem 3.1. All right angles are congruent. Theorem 3.2, if two lines are perpendicular, then they intersect to form four right angles, as you see here. 1, 2, 3, 4. In these angles here are all right angles. And if we write it in mathematics, it's written right here. It says that if n is perpendicular to m, those are the two lines that they're referring to, then angle 1 is 90 degrees, angle 2 is 90 degrees, angle 3 is 90 degrees, and angle 4 is also 90 degrees. These two theorems are really useful, especially 3.2, but I don't want you to memorize all of the wordings. I want you to be able to understand it. So one way to understand it is to prove it to yourself. Theorems can always be proven, right, with the given information. That's by definition. So let's see. If I have two lines, M and N are perpendicular, and as it's shown in angle 1, we have learned about vertical angles already. So if angle 1 is 90 degrees, angle 3 must be congruent because they are vertical angles. So angle 3 would be 90 degrees as well. Now, if angle 3 is 90 degrees, angle 3 and angle 2 forms line N, and that's 180 degrees, straight angle. 180 minus this 90 degrees, that will give me angle 2 as 90 degrees as well. And again, angle 2 and angle 4 are vertical angles, and by definition, angle 4 is 90 degrees as well. So a very simple condition that two lines intersect and they're perpendicular to each other, all four angles are are right angles at 90 degrees. Okay? Let's look at this example. In the diagram, R and S are perpendicular. No, that's not R, sorry. R is here. R and S are perpendicular at angle 5, and R and T are also perpendicular at angle T. Decide whether enough information is given to conclude that the statement is true and explain your reasoning. So for A, angle 1 is congruent to angle 5, and this is true. And the reason is that when the angle measures of 1 is 90 degrees, and the angle measure of 5 is 90 degrees because they're both perpendicular to line R. Therefore, we can conclude that angle 1 is congruent to angle 5, right? And angle 4 and angle 5, do I have enough information to prove that angle 4 and angle 5 are congruent? The answer is yes, I do have enough information because I know that angle 1 and angle 4, angle 1 and angle 4 are congruent, and that's because they are vertical angles. Vertical angles, not vertical triangles, vertical angles. And therefore, because angle 1's measure is 90 degrees. The measure of angle 4 is also 90 degrees. Now, because measure of angle 5 is 90 degrees, so now we can conclude that they are of the same measure, therefore angle 4 and 5 are congruent, right? Third one, I'm going to do it up here. This is C here. 2 and 3, are they congruent? I don't have enough information. Not enough info. Because I don't know. I know that 2 plus 3 together adds up to 90 degrees, but I don't know what this line is. If this line happens to be the angle bisector, then yes, it will cut my straight angle. I'm sorry, it will cut my right angle, this big right angle, into half. That would have worked. But because I wasn't told if that line is a bisector or not, it's inconclusive. I cannot draw any conclusion. Here's some practices. Give it a try yourself. If you need help, make sure you ask me or ask your fellow classmates. Here are another two theorems. The one on top, 3.3, says, if two lines intersect to form adjacent congruent angles, then the lines are perpendicular. Notice that this 3.3 is just the opposite of 3.1. In 3.1, we said if the lines are perpendicular, then I have 4 right angles, right? 4 90-degree angles. And then this one is saying that if the two lines intersect to form adjacent congruent angles. What this is really saying is that angle 1 and angle 2 has to be the same. But notice angle 1 and angle 2 forms 180 degrees. Ooh, I'm proud of myself. Look how straight that line is. But back to our lecture. Angle 1 and angle 2 add up to 180 degrees. If angle 1 and angle 2 are congruent, that means that they each are 90 degrees. So what this is really is saying is that if my angles are straight angles, then my lines are perpendicular. So it's just the opposite of 3.1. So here, if we use mathematics, we say if angle 1 and angle 2 are congruent in our diagram right up here, that means AC and BD are perpendicular to each other. And in fact, these are 90-degree angles. Now, Theorem 3.4 says if two sides of the adjacent acute angles are perpendicular, meaning if EF is perpendicular to EH, then these two angles add up to be 90 degrees, and they are right angles. If two sides, meaning this is one side of angle FEG, and this is the other side of angle GEH, if two sides of the adjacent angles are perpendicular, then the angles are right angles. So let's look at how we use this one. In the helicopter at the right are AXB, which is this angle here, and CXB, which is this angle here. Are they right angles? And if so, how do you explain that? So if you recall 3.3, by theorem 3.3, AB intersects with BD, right? So I'm sorry, AC intersect with BD, and they are perpendicular, forming for, sorry, that is forming. Let me respell that. For right angles. Whoops. Therefore, angle AXB is congruent to angle CXB because they are both have the same angle measure at 90 degrees. Okay? So that's the thought process behind it. Look at this one. This one is practically the same type of question, but they just threw a little bit of algebra in there. So it says in this diagram, FE is perpendicular to HE, or EF is perpendicular to EH. And the angle GEH, which is this smaller angle here, this angle here is 30 degrees. And find the value of y. How can we establish a relationship? How are they related and connected with each other? So if we know that the angle measure of FEH is 90 degrees, we also know that the angle measure of FEH is composed of the angle measure of FEG and GEH. And since we know FEG is 6y degrees and GEH is 30 degrees, and we know that FEH is 90 degrees because it's a straight angle, then we can simply do our algebra and solve for y equals 10. And if I plug it back in, 6y is 60. 60 plus 30 is 90 degrees. So I just verified that I did this problem correctly. And here is my final answer for y. Here are 2 checkpoints. Again, make sure that you take full advantage of the perpendicular lines and the 90-degree angles. It makes life a lot easier. Thank you, guys. Bye.